Welcome to Rewind, the show where we look back at the game industry's past as we build the games industry's future. My name is Melissinos, and I'm the Principal Evangelist for the video games industry at AWS, and your host of Rewind, coming to you live every Friday from 3 to 4 p.m. Eastern. Now make sure you hit the like, follow, and subscribe buttons on Twitch and YouTube so you know when we go live, and it really helps the channel out. Now, on today's episode of Rewind, I sit down with Steven Hugg, the founder and creator of the 8-Bit Workshop. Steven is also the author of Comet Busters, a popular shareware game for Windows 95. And more recently, he created the HeyTell voice messenger app. And he's a big fan of retro gaming and the 6502 CPU, and he still has his old Apple II computer. Now, the 8-Bit Workshop provides an IDE that gives developers the ability to program games and applications for some of the most iconic game consoles and classic computers like the Atari 2600, the NES, ColecoVision, Apple II, Commodore 64, and more directly in the browser, along with the variety of tools to help create animations, music, and sharing your creations. This site is an exceptional resource for anyone looking to program for these classic systems. And of course, Steven runs his site on AWS, and we are thrilled to have him on the show today. So, without any further ado, let's jump right in and meet Steven. Steven!
Hey, Chris.
Hey, buddy, how are you? All right, look at that little applause for Steve. Thanks for joining us this afternoon, buddy. We really appreciate it. I'm going to go over and turn the applause down a little bit. This audience gets a little rowdy and out of control. Isn't that right, kids? Yay! Of course, of course. All right. All right, let me turn that applause down. Yeah, very enthusiastic audience. Very enthusiastic audience. So, Steve, hey, thanks again so much for taking time out of your Friday afternoon to spend it with me. Really excited to have you on the program.
Yeah, me too. Glad to be here.
Awesome. All right. So people may go ahead and start just jumping over to the URL, which is right there at the bottom, https 8bitworkshop.com. But maybe you can tell us, what is 8-Bit Workshop?
Sure. Well, 8-Bit Workshop is a web-based tool that allows you to develop video games from the 70s and 80s mostly, right in your browser. You don't have to install any compilers or any assemblers or any other software on your computer. It just runs in your browser. It saves all your work. It compiles it compiles or assembles your program into a ROM file, which then is emulated on the right side of the screen. And you can just keep writing and testing your game, writing and testing. It shows up immediately after your code compiles. And that's how you make a game. All right.
Okay. So that's how you make a game. That's,
it's just that simple.
Of course. Exactly. Right. It is just that simple. Just jump in and start creating your games. But in all seriousness, I mean, the fact, what really attracted me to the site was the ability to go back in and rediscover old systems that I just hadn't seen code for in many, many years, and the ability to go ahead and start playing around with them and kind of reacquainting myself with how games were written on these older machines was just fascinating to me. And a colleague over here at AWS, Chris, said, hey, man, have you ever seen this website? You need to go check it out and maybe have them on the show. So I was like, that is a solid idea. So that's how we kind of got connected. But all right, so you built this website, but like, why did you start developing this? Like, how did it start?
Well, originally I was, the first version came when I was trying to learn how to program for the Atari 2600. I guess I was bored and I wanted, to finally learn how to program games for the Atari. So, I sat down and kind of figured I need like some kind of editor. Wouldn't it be nice if I had the emulator and the editor side by side? And I thought, well, I could do this in a web browser and then I can just write a little quick thing to assemble the code and show the emulated ROM file. And it started there, and then I said, well, now I can do arcade games too, can I? I can get a C compiler, I can get a Z80 assembler. I added that in. I need multiple files now. Oh wait, I'm making a debugger. I'm making all this other stuff, and it just kind of snowballed from there. So it started because I was bored. And I'm sorry, I can't hear you.
Yeah, like so many wonderful things in life do, right? Starts from boredom or a need that wasn't being fulfilled by somebody else. But why game development? You know, is your background in video game development, or maybe tell us a bit more about your background?
Well, of course, like many of us, I wrote lots of weird little games on my Apple II. So I guess that's my first non-commercial game development. And I wrote, and then in the 90s, I used Turbo Pascal a lot, if you remember Turbo Pascal for the PC. And I did a lot of stuff in that. And when the Turbo Pascal for Windows came out, I did Comet Busters, which is kind of a rock shooting type game, which got kind of popular in the shareware circles.
Yeah.
And so that's my biggest published commercial game. And I got fan mail, and little kids drew me little stuff in color pencils. That was kind of cool. And,
that is awesome. I'm so glad you brought up Turbo Pascal. That is the only language that I actually learned from a class, right, in high school, was programming Pascal. And I loved it because it was so easy to actually debug your code and understand what's going on, because you had all your global variables at top, then you all your setup and structure there. It's kind of in many ways similar to HTML, right in HTML, where you've got all of your global parameters, you have individual parameters up top, and then you're writing all of these blocks and nested loops underneath. But you could always go back and have a central place where you weren't going ahead and popping variables down in different lines or creating generators or things like that. Really, really well thought out, and just a lovely, lovely language to
it's still around. There's something called Turbo Rascal, which is a kind of a 8-bit fan Pascal compiler. So one day I'll have to write a game in that. But
that's right. Well, you have enough on your plate. We're gonna. I can't wait for us to go ahead and dig into the environment. But before we do that, I want to also ask a couple of questions about your approach to creating these IDEs in this environment. Why the browser? Well, why not create just a downloadable application where people can go ahead and run it? Like, why did you choose to write this in the browser?
Well, the browser is kind of the default platform for a lot of computers. Runs on Mac and Windows and Linux and Raspberry Pis. I developed a lot of this stuff in my Chromebook, and it's slow, but it worked, and the battery lasted the whole day, so that was kind of nice. And it's fast enough to do emulation. There's a WebAssembly. We use that in some of the emulators, and there's no need to install anything. The sound graphics just work most of the time. And it's also, the JavaScript is backwards compatible to, years and years. We have very few instances where I had to rewrite something because the language changed, right? So in a pretty stable environment. And the lifetime of this stuff lasts for, decades potentially, right? Because I'm using tools from like the 2000s in some of these places. So I wanted to have a very long life and not have to keep constant maintenance. So it's been good in that respect.
Yeah, look, I completely agree. And, as we were talking about before we went on air here, I'm also maintaining multiple chat windows, making sure that if anything pops up that we're capturing those. But, I really do believe that the browser, once again, is in a position to change the way we deliver content and interactive entertainment that allows for anybody across any device to be able to just jump in and start to engage. And that's what I love about 8-Bit Workshop is the accessibility, as you point out, through any browser. It meant that I could go ahead and touch the environment from a myriad of devices. So I didn't have to worry about if I was on an Android tablet or if I was on a Mac or I was on my Windows desktop. I had access to this environment to play around, to learn, to discover without having to worry about downloading for each one of those. And I'm sure as a developer for you, it means that you don't have to go in and maintain multiple versions of it. You create one version, it just runs everywhere, right?
And that's another thing, is you can just hit a hyperlink and load someone's project into your browser, and it's good for sharing stuff, which is one of the whole points of doing this kind of game development, is sharing and remixing stuff.
Oh yeah. And we're gonna dig into all of that too. But before we jump over, just a couple more questions for you. So I looked through, the selection of the systems that you have there. Some I'm really excited to show off today. how did you decide which systems to go ahead and use? Were they built around a particular architecture? Were they ones that meant the most to you when you were a kid learning to program? Like, why did you choose the systems that you did for 8-Bit Workshop?
It's a good question, man. Kind of all of those attributes. You know, the first is it interesting? You know, the Atari 2600 is kind of unique in the way you program for it. It's very constrained and it's hard to emulate. So that had to go in. But then I started thinking about arcade games, and it's a pretty good fit because they're very simple under the hood. Like there's just a CPU and some memory, and you know they're easy to emulate, easy to understand. So I did a lot of stuff like the Galaxian hardware and the Atari hardware. And also I wanted to have not depend on a lot of external software. Like I didn't want to have a copyrighted BIOS or any, you know, I don't want it to be too big either, because then you have this giant support software to worry about. So it has to be kind of in the middle, not too small, not too big.
Yeah. And I think you did a really just fantastic job with selecting ones that not only fit those requirements, but are also iconic, right? They're ones that those of us in the games industry, or not even the games, those of us that grew up in the era of the bedroom programmer, right? And learning how to code through magazines and things of that nature. These are the ones that even if we didn't own a C64, I couldn't own a C64. Oh, yes, Gorf laughing at me. I couldn't afford to own one of those. We had a VIC-20, right? 3,192 bytes of memory, right, after booting. But these are the ones that, you know, emotionally and from a nostalgic point of view, just really hit all of the right chords and beats, right? And it's ones that are also still massively recognizable by a mass audience even today, even if they never grew up with these machines. They understand, you know, by and large, where these sit kind of in the pantheon of compute and compute technologies over the years. So good job. Little air horn there for that one. Good job on that. So for your day job, we were talking a little bit about this before we got on air here. This is now your full-time job, is maintaining 8-Bit Workshop and all the things around it. What else does your company do besides these web-based IDEs?
This is the main thing we do. We 8-Bit Workshop and selling 8-Bit Workshop books. That's pretty much the focus. I also maintain the Haytail app on the side, but that's a different story.
All right. Well, very good. Well, those are all the questions that I've got for you leading up into this. So why don't we go ahead and jump in and check out what 8-Bit Workshop is all about. So let's go ahead and move on over to that screen. All right. Ooh. So here we are. We have the 8-Bit Workshop up here, and maybe you can walk us through.
Yep.
Yeah, let's go ahead and jump right in and start walking us through the site here.
So this is a welcome page, and you can read all about the different platforms if you scroll down, or you can jump right in and hit the big button to hit the ID. If you scroll down, you can see the list of platforms at the bottom. So a screenshot of each one, and click the link to pick a platform you like and jump right in, and it'll open some example code to get you started.
All right. So yeah, so let's go ahead and, let's go and start off with the iconic one, right? Probably one of the most iconic, at least for my generation, the Atari 2600 or the VCS. It's VCS for those of you that are in the know.
Yeah.
That's right. The Atari VCS, nice. The video computer system, right?
Depends if you bought it at Sears or, mail order, I guess.
That's right. And Sears, it was the Tele-Arcade systems, right? Sears, Tele-Arcade. And there's a whole story behind why that was so important to the launch of the VCS, but that is for a different conversation.
Yeah, a lot of stories involved with all this stuff. It's kind of interesting.
That's right. And I just lost part of this because I decided to resize the window. And that's what happens when you do this in real time. So now I'm not going to move my window anymore. All right. So, but maybe go ahead and walk us through what it is that we are looking at here when we first jump in.
So when you first jump in, we have a bunch of different code examples. This is the first one. On the left, the big code fragment there is assembler code, 6502 assembler code. The 6502 is the CPU of the Atari 2600. So you see on the left, the little numbers, the hex numbers on the left, that's your program being disassembled, or actually being assembled. Oh, what happened? I didn't do that. Can I hear you again? What happened?
Oh, what happened was I went on mute and then I went ahead and turned on the mouse pointer on the window so that way I could go ahead and point to what you're describing. And then OBS decided to grab the wrong window. But now we're all back and good again. So, so here we are on the left.
Yep. So that's that is your assembler code being assembled into these little hex bytes. So and that's helpful because on the Atari you have to count every single cycle, and CPU cycle, and every single byte of code. So that's a little bit of help there.
Oh yeah.
And the little 2s and 4s, that's how many CPU cycles each instruction takes. So you can, if you need to count for some reason, and you often do, you'll have that available to you. And this is a very simple program that doesn't even generate a proper video frame. On the Atari 2600, you have to make your own video frames. There's no frame buffer or anything. You have to like program every single scan line. So that's why you see on the right, the emulator is your Atari emulator making a fuss about the all the wavy lines that are happening. So, but you know, there's a bunch of comments that kind of help you follow along. The books will help you follow along, and then you just kind of make your way slowly to building sprites and backgrounds and stuff. So,
and this is what I love.
Debugging. I see you're hitting the debugger.
Yeah. So but before we do that, so what I was going to say is what I loved about this when I first experienced the site, right, was the fact that so much is commented in there in the examples that you give. So it starts to help you relearn, right, and understand exactly what's happening here. You know, and when you talk about the VCS and limitations of the VCS, you know, a lot of people that have never programmed on these really fundamentally anemic systems, they were not. I mean, the Atari VCS was designed to do one thing, really: play Pong and Pong variants. That was it, right?
Combat, tank and Pong, tank and breakout, really.
Right, exactly. Which, okay, you know, there's certain modes in combat where you are bouncing the missile off of or the munition off of different walls, right? And so things like there's a wonderful book called Racing the Beam by Ian Bogost, and he talks about how, to your point, you'd have to the program would have to count cycles, understand where the electron beam was in its painting, right? Whether it was in an odd or even scan line going down a CRT, and then be able to go ahead and remove a piece of graphics from the memory while it was in mid-cycle, open up that memory space, load in a new color or a new element. So by the time the electron beam got to the bottom, it went back to the top. It was painting in the new image, color, sprite, whatever that you wanted to see. So literally the system is building what you're seeing on the screen at 60 hertz, right? 30 and 30, frames per field, and tricking you into believing that Pitfall had all this memory space to paint the trees and everything else, when in fact, you know, you're only that it's removing stuff from memory and repainting things faster than your eye or the TV can perceive them dissipating or disappearing, right? And it was really just incredible, really incredible.
Might be good to hit another example to show what it looks like when it's drawing an actual animation, like.
So let's see. I've got
little pull down at the top where it says Hello 6502.
Yep, I've got the pull down. Unfortunately, the way screen grabs are done, you're not necessarily going to be able to see that. So I have to pull down here. Hello 6502 and TIA, painting on the CRT, playfield graphics, players and sprites.
Sprites sounds good, I think.
Let's see, the players and sprites. This one here.
Yeah, okay. There you go. There's some sprites for you. So
yeah. Painting
not very good, but you can make really good vertical sprites that go all the way down the screen. So that's kind of one cool thing about the Atari.
Yes, yeah, exactly, and all the color banding that they have in there. So you're able to go ahead and actually pause, see where you paused in the application. You can go ahead and actually then drop into any one of these registers, and then it will move you over to the code so you can understand what is being called and invoked. So you start to build this understanding of what's going on inside the system. And to your point, how many cycles it takes. I didn't realize that that's what those numbers were denoting, that those are cycles that it takes for each one of these.
76 cycles per scan line, and you can only do so many things in 76 cycles. So you have to do a lot of dancing around to get it done in time.
Yeah. Somebody just posted here into the chat. Glitch said 10, make best game ever. Semicolon 20, go to 10, right? So there you go. That sounds like an AI driven request, not a 6502 driven request, right?
One day, get done one day.
That's right. Okay, so we've got players and sprites. Let's see. I apologize that for some reason we're not able to capture the pull down here. So you probably have them all memorized, Steve, but if not, maybe pull up the IDE on your side and then tell me what you would like me to pull up. So for instance, like this complex scene 1, right? Now we're starting we're starting to get into more gamey like examples versus just understanding how the system is working, right?
I wonder if you can pull the left toolbar out, and if you go to the left side and pull all the way to the left, there might be a way to expand the window there.
Yeah,
you can see the tools, which are kind of hidden at first.
Okay, so here's what we're going to do, folks. I am going to see if I'm going to adjust some of this out. And nope, we're not going to be able to do it that way because of the way, once again, OBS is capturing the screen. So unfortunately, I can't drag this out. And oh, wait a minute.
Oh, there you go. Okay.
Yeah, it was going in the other direction, to the right, not to the left. There we go. Oh my goodness. Thank you. Good job, Steve. Good job.
Hey.
All right. Okay, so maybe walk us through what we're seeing here.
Sure. So it shows you all the different files that are involved with this program. So there's the vcs.h has your all the definitions of macros and definitions for all the VCS hardware registers. So there's a register to set the background color, the sprite color, and do timing kind of things. It shows you all the bits that are involved in each register. The sound registers, for example.
Yeah.
And if you go down to, let's say, there's some debugging tools down there. Like if you go down to memory browser, you can see a dump of the memory and all the different variables in your program. So we have the labels of all the registers and the different parts of your program. You can see those changing in real time as your program runs. Oh, so if you were to like move the joystick around, you'd see like your position change if you can find it.
Yeah. Let's see if we can find.
You have to go to the very top of the program, where the RAM is all at the top. So those are your registers for the Atari chips, and down below. And
there we are. So here, my X position is changing.
Yep,
right
there you go.
85, okay. And then my Y position is changing.
Yep. So you know it's working.
Yeah. Oh, that's fantastic.
That's basically how you do debugging. If one way to do debugging is just watch those numbers change. And memory map just gives you an overview of the different areas of your address space. So you have 16 bits of address space, 65,000 different locations, and you only use this fraction in the Atari. Mm-hmm. But it helps you get oriented. If you know the system, you can look at this and say, okay, here's where the RAM is, here's where the ROM is, and kind of get a feel for things.
Right. And so obviously in a system, again, as rudimentary as the VCS was, we don't see things like bank switching and things like that typically.
In some cartridges, you have bank switching. Yeah, later.
If there's extra memory, right? If there's extra memory on the cartridge, they were doing bank switching on the cartridge, or were they actually doing it in the original stock hardware?
No, the stock hardware doesn't know about bank switching, but they put circuitry in the cartridge to implement bank switching, and they can do more than 2K. Like Asteroids had more than 2K or 4K or something.
Yeah, and Pitfall 2, right? Also,
Pitfall had a whole other chip or Pitfall 2 had the extra chip that lets you do crazy things. But yeah, Pitfall had bank switching. Yeah,
and it was the first Atari VCS game that had a full soundtrack, full music soundtrack that played through the game, right? In the background, right? Instead of just beeps and boops.
Yep. If you program with this, you'll see how you can't put much music into 4K. So
Right.
big achievement.
And then we have
And the memory map.
oh, sorry, go ahead. Yeah,
Sorry,
there's the memory map.
these two things, the memory map and the memory probe, they show you the memory as it's changing, which you can't see much going on here because there's not much memory to change. But
Right.
in other systems, you'll see it read and write. You'll see the different accesses of different parts of memory. So, and you'll see the code execute wherever it is.
Yeah, what I can see
pretty static scene, so you don't see much changing.
Yeah, what I can see at the bottom of the screen that's being cut off because of the formatting here is I can see the memory map changes. I'm moving, or I can see what's lighting up in memory as I'm moving a character around the screen, but that's cut off at the bottom of your screen there. So my apologies.
Once you mouse over, you can see the different locations it's changing, which is helpful for debugging and understanding things.
And which I think is also, again, a really important thing, right? To have a visual component, not just a wall of text, right? And where you're trying to find this, but being able to visually see what's going on too, right? Allows you to quickly identify problem areas, places you didn't know, or, bugs that you needed to go ahead and fix that you can drill down into. Right. So I think that's
sometimes you can see the visualization, instantly know what's going on, and that's pretty helpful.
Very cool. All right, and the CRT probe.
Yeah, that just shows you, it shows you what happens on your monitor as it's scanning through the different scan lines, and it's showing you the relationship between the screen and the CPU. So I think on the left would be the part that's invisible, before the actually starts drawing the red stuff.
Okay, yeah, and so right now as I'm moving the character left to right, you can see it moving at the top, and then as I'm moving up and down, you can see the basically the position of the gun, right, for where it's drawing in the CRT field. Is that correct?
Right. It shows the CPU to work to draw, so it's showing you that what the CPU is doing.
Very cool.
See on the left, there's all these red spots, which means it's hardware registers, which set up like the background and the colors and stuff, and then and then the green stuff to finish. So
very cool. All right, the probe log.
So that's
okay. The probe log here. Oh, I think we lost where
probe log. Yeah, that single cycle in the frame.
Okay. And then we have the scan line IO. Our symbol profiler, the call stack. I think we may have lost Steve. Oh, we lost you there.
Of like what if you oops, sorry.
No problem. Yeah, we lost you there for a minute. Yeah, you're back. You're back.
I guess you should have. I can't tell if you heard me or not.
I did not. I did not.
Wi-Fi. What am I doing?
That's okay. Maybe shut off your camera and then turn it back on Zoom and see if it'll pick back up, right? See, that's how you know it's live, folks, is the internet.
That's good.
All right. And then we have our asset editor as well. So you can go in here and look at that. And actually, we're going to go and take a look at the asset editor in a little bit. But again, so you have a full development IDE right inside of the browser, and all of these examples that you can that you can basically learn from, right? Oh, you know what? I mentioned bank switching. Yeah, there's your demo for bank switching right there. So perhaps I should have went ahead and looked at the pull down list before I mentioned that.
Am I back? Hello, can you hear me?
Yep, I can hear you. Yeah.
Good. Sorry.
No worries.
So you made the bank switching already, huh? You're ready to write that game?
No, not quite. But I love you have examples in here for things like joysticks, right? To explain how to go ahead and measure trap input and do these sorts of things. Complex scene 1, that's the one that we were just on. Complex scene 2, let's take a look at that one. Even more complex. Go ahead.
It's just how many lines, how many sprites you have and how many scan lines per background cell is a little different, but it's it's a lot different in how you program the scene, just because Atari is so strange. So,
Yeah, it is a strange little machine, isn't it?
yeah.
And then your scoreboard. And let's see, what else did we have in here?
Another difficult thing to do is just drawing numbers is, not taken for granted. You have to work hard.
Yeah, you do, right? There is a reason why, and maybe you could explain why. There's a reason why in certain games. So, for example, I remember in Space Invaders, the numbers all had black lines going through them, so they weren't painted as full, solid colors like this. Or you may have had horizontal line in a number that was offset from another number that had a horizontal line that was higher, right? Did that have to do with memory limitations? Did that have to do with sprite limitations or drawing limitations? Why were there these variants with the way we drew numbers on the VCS?
I don't know. I mean, I think my initial thought is that you only have time to draw the first player's score, and then you have to wait another scan line to draw the second player's score, and they alternate lines that way. That's and that could very well be it. That I'm going to go back now and look at them. It could very well be that the other set of numbers were offset by a scan line versus the other one, so it's drawing one number on the odd pass, the other number on the even. That could very well. Look at that. See, we just figured it out. Yay! All right. We did it. Right. So getting a scoreboard up there, and then having things like, tiny text. This is super interesting, right? Yeah, that's actually done with sprites. So the scoreboard you saw was done with a background, which has chunky pixels. This has, fine pixels used for sprites. So with some various tricks that were not known at the time of the VCS's construction, you can do more than 2 sprites per scan line, which gives you this wide, text display. But it's really convoluted. I think there's self-modifying code involved and stuff like that. So to get those things done in time before the scan line ends, it's a lot of effort. So
yeah, and what I love is the demo or the examples you have here. You really go into really good detail about this, right? We can draw scoreboards, other kind of text using the playfield registers. They're pretty blocky, limited to 40 pixels. I mean, you explain very well, very clearly, not just what it is that you're doing, but how each line in the program or each section of the program is contributing to the overall, what it's doing in the program, right? In their loop.
I have to, because I'll forget how it works if I don't comment. So it's mostly from my benefit. And I'm glad it helps you too.
Yeah, it does. And again, it's one of the things that made me kind of go, man, I'd totally forgotten how to do some of this stuff. And so now it's got me going back and dusting off some cobwebs in the back of the brain there, right? And remembering how much fun and complex it was to actually try to write. Let's see. All right.
It's fun. Like Dwarf Fortress was fun, big sense of accomplishment when you win.
Yeah, that's the thing. And I've tried to explain that to my kids that don't have an interest in like computer science and programming. They just don't. I'm like, when you learn to program, it's that moment of, I can't believe I figured out this puzzle and I got this thing to execute on screen, right?
Right.
I think the last big kind of program I was doing was actually like database scripting platform for like telecommunications companies and stuff, and going, how come these fields are breaking? How come it's not pulling? And at 3 a.m. when you jump up and go, and you figure it out. And the fact that you have this available through a browser means that I can just grab any of the devices that are close to me when that inspiration strikes, jump right back in and see it work. That's pretty awesome. That is really awesome. Really, really cool. Okay, so so again, what Steve has put together here are all of these, awesome examples that you can go ahead and dig into and start to understand how a system like the Atari VCS or the 2600, as some recognize it.
You found a basic, but there's a thing called Atari Basic, which is kind of a little quirky basic compiler.
Yeah.
And I haven't written anything in it, but I stuck it in there because it might be fun to play with. But
it is very cool. And it's certainly not the.
That's a lot of heavy lifting for you.
but it's also certainly not the Atari Basic that we had when we had a VCS and we got the keyboard pad, right? And you tried to, and I was talking to a very good friend, Mike Micah. He was on the very first episode of Rewind, and we were talking about programming for the VCS. And he's like, yeah, when we got that, when we were kids, I'm like, this is how Atari games are made. I'm going to make a game.
I'm sure not.
No,
that was the one with the spaceship art on the cover, I think, or the people wearing the space capsule programming basic.
Yeah. There's a wonderful book called The Art of Atari by Tim Lapatino. Fantastic book that goes into the artistry of those watercolor covers. And it certainly created the illusion that these games and things were much bigger and more capable than they were at the time. Okay, so we have the
just to make that basic cartridge was a big effort, though. I mean, it's really hard to fit basic into the system. So, as silly as it was, it's amazing that it got done at all.
Yep. Oh, I'm sorry. I pulled up the wavetable sound here.
Oh yeah, this is a not very good music.
Hey man,
I think it works better on a better emulator, but.
That's okay. This sounds just like the Atari, so not a problem.
Yeah.
All right. Why don't we jump into another system? What system would you recommend we jump into next? We've got on our game consoles here. We have Atari. Oh, we have the NES, Bally, Astrocade, ColecoVision, SG-1000, Master System, Game Gear, the 5200, and the 7800. If we had to look at another console, which one would you pick?
I mean, do you want to do ColecoVision because it's so popular?
Yeah,
ColecoVision.
NES gets so much love. ColecoVision, which also shared a lot of the same architecture as the MSX platform, right?
Because it's the same chipset basically. It's just connecting different components to them, and so that's why I have the MSX emulated here, and also have the Sega SG-1000, which is really almost identical to ColecoVision. Yeah. And they actually share a lot of the same code examples because they're so close. But
very cool. Very cool. All right. So we are here on the ColecoVision. So what would you recommend that we look at first?
One of the games, maybe the Solarian game or the Climber game.
All right. So here's the Solarian game. What does this look like, everybody? No, it doesn't look like Gorf. But it is a competent Galaxian Galaxian.
Inspired by Galaxian, let's say.
Inspired. I like that.
Yeah. So this is one of the examples of almost full game examples I use, and I've ported this to different systems in 8-bit Workshop just to see how the systems differ. And you have to do a lot of different things with each console. Like I think for this one, the formation is actually background tiles, and that when the aliens are in formation, they're background tiles, and they're sprites when they turn red and dive to you. So that's how to get around limitations. And I think that's similar to how Galaxian Arcade actually did it too.
That is similar to the way NES games also worked back in the day, right? They couldn't have enough sprites in there, so you were actually just seeing the background being manipulated, and then collision points were represented by sprites, right? So
you didn't notice because they look the same when they're in formation versus sprites. So
exactly, but this is the whole point, right? Is that it just needs to look right for the person that's playing, right? They don't need to know that the hardware can't do what it's seemingly doing. It's part of the illusion, the magic, right, of game development, especially on these more anemic systems. And then of course we had our Climber game there, which is also brutally hard, because I was trying to play through this before. Let me see, can I jump off of space button or the shift button?
It's one of those games where you have to have exactly the right Y position to get off the ladder, which is really, I'm sorry about that. But
no. You know what game did that too? Oh, and I hit the wrong button there. There's my jump button. Burger Time. Burger Time was the same sort of thing, right? You had to be so damn precise with that game that it made it I mean, when you died, you're like, that's cheap. Right?
And it's just so slow, but it's so brutal when you get hit by egg and a sausage.
Oh yes, absolutely. And so as you mentioned, you can go through and actually see what's going on in memory as the game is playing. You can your view. This one, right, of course, had there's an extra. ColecoVision and NES have a different bank of RAM for graphics, and that's a different way of programming. So yep. No, really, really cool. But again, the fact that you can play the game, start coding, play it, see what's going on, stop, figure out where the issues were, go and fix it, play again instantly, all in the same IDE, all from the same browser window, is just extraordinary. Just really, really extraordinary. Not just as a teaching tool, but just as a development tool, because you can program full games here and get them out of the IDE to use externally. We're going to talk about that in a minute, because there is one function that I found in here, and I told Steve before we got on air that I was like, "Oh my God, I can't believe you have this in here." But I digress. Let's also
we'll wait for it.
Yeah, let's go take a look real quickly at. So you've got other computers in there, of course. But let's go take a look at real quickly arcade systems, right? I think the Williams is one that you recommended. And the Williams arcade platform is one that basically produced some of my favorite games, including my absolute favorite game of all time, which is Robotron 2084. Greatest arcade game ever made. And Eugene Jarvis is a mad genius. So here's your Williams Z80 based system.
It's not actually a Z80, but when I did this section, I didn't have a 6809 tool set. Now I do, and it's almost there. But the Z81 is it's the same concept, just different CPU.
Yep, and
I guess the Williams game could be made with the Z80, so it could have happened.
Yeah, and look, you happen to go and pick a twin stick shooter Robotron style game as the demo, my man. So yeah, really fantastic. You know what I love about this game too? Having one of the cabinets in the home, it's when your kids, their friends would come over and they're like, "What is this game?" And you're like, "Yeah, just go and play." And they would touch these two joysticks, the game would start, and boom, they die. And boom, they die. And they're like, "What happened?" I'm like, "See, games were hard when we were."
You have to really get in the flow state for that one. I mean, every time I go to the arcade, it really just
yeah. Well, there is the story about that where I guess the very first run, it could be a bit of lore, but this is the way the story goes, is the first run of Robotron cabinets that went out there. People were shaking the machine so hard by the joysticks that they were ripping them through the wood panel, and so they had to steel reinforce them. So there's a steel plate under them, so you couldn't do that anymore, because it was
a lot of the ones I've seen lately have been kind of shaky, so I'm surprised they still work. They probably had to get replaced a few times.
Oh, for sure. But yeah, so you could go ahead and build games, applications, and just learn about these systems that were fundamental and foundational to game developers and just amazing. Let me answer this question here.
Work if you hit the asset editor link.
Sorry,
this is just a rudimentary sprite editor.
Oh, sorry. Which one now?
The asset editor at the bottom
Let's see.
of the left
asset
panel.
editor. There we go.
Then you can see all the colors and all the sprites used by the game, and it's a very basic sprite editor. You can play. This is how you can play around with stuff if you don't want to program.
There you go. So you have a sprite editor in here, but you also have another tool, and we're going to go and jump into some of those real quickly here as well. So here's the sprite editor.
As soon as you modify, it'll recompile everything and put it back in.
Let's see. Yeah, you can see right now I'm just coloring in an ominous red eye on the main character, and you can now see that in real time. There it is.
Now he is a Robotron.
Huh?
Now you've made the Robotron. That's a robot, man.
There we go. Exactly. It's almost like one of the big brains, right?
Right.
So, all right. So not only do you have these tools here, including MAME and different interpreters.
Some of the emulators we have MAME. It's a little slower than the default emulators, but it's good for testing on different emulators right in the browser too.
Very cool. Very cool. Of course, your BASIC and your Z Machine. For those that don't know what Z Machine, this is text-based games, right? So these are your the Zorks and Infocom games, right? Oh, look at that explosion. That was fantastic. It scared me. I forgot we had that going. So what's really cool now, one of the things that we were talking about that I discovered recently was writing these games, and I want to go ahead and now get this thing out and play it or share it with other people. And there are a variety of things that you provide through 8-Bit Workshop to do so. One of them is the ability to go ahead and share a playable link or record that video. So people can write their applications and then send a link to friends and they can play it in the browser. That's correct?
Yeah, that's it works best with small ROMs. It actually encodes the whole game in your browser. So with Atari games, you can actually, base 64 encode your ROM in your query string, which is a little silly, but it's so short that it works. But
very, very cool. And then being able to go ahead and export this as, let's see, where was it?
File export, or you want to?
Oh, it was download the ROM image, so that way you could take the ROM image and then go ahead and put it into an emulator. And one of the things we talked about was, because it's just a standard ROM image, there are ways to go ahead and put it onto original hardware like EEPROM cartridges and stuff like that. Even though we talked about not having done that yet, there's no reason why it shouldn't go ahead and work. But here's the coolest one on here that I loved, and it is. Did we do it in?
It'll probably only be shown in the certain platforms like the Apple II or.
Yeah. So let's go ahead and look at that. So for the Apple II, when you share, make cassette audio. For those of you that don't know what that is, this is the ability to go ahead and record the code out onto an audio cassette and then being able to load it into a machine through an audio cassette. So when I was growing up, we had a VIC-20 with a data set recorded. That is how we went ahead and recorded these things. If you ever put one of those cassette tapes in a boombox, you just heard all the scratching and screeching that most people associate with fax machines or AOL, right? Getting online. But that is how you were able to get these machines out. And the fact that you have the ability to do that, man, that makes my heart so happy, right? To see
I have done that in my Apple, so I have. You can just plug the file load the file into your iPhone, and then plug an audio cable into your Apple or your whatever, and you can type load on your Apple, and then press play on your phone, and then it loads it right from the audio file.
That is amazing. Really, just
it's like the only way to actually get software from the internet onto these old systems, really, because there's no other interface that works anymore.
Yeah, absolutely. You also mentioned too, as we're coming up to the top of the hour, about Verilog. Do you want to tell us about Verilog and what this is?
Well, Verilog is a hardware description language, which is a language for designing chips. So with this system, you can model like the original Pong in the circuits. There's no software here; it's all just logic gates. And this helps you build these systems. So. People have built their own CPU in this. You can build like an entire game console in this, and it kind of almost works at a decent speed on the browser. Not an N64, but you can build like, your own game console with your own CPU.
That's amazing. That's really extraordinary. I mean, and again, also learning how these discrete circuits and systems worked. When you look back at the very earliest games, like Asteroids, for example, in the arcade, right? Each one of the sound chip was a discrete analog channel. There was no, chip. There was no silicon-based, audio generated. These were discrete circuits that created all of the audio that you saw there. And so you could replicate that in Verilog.
Yep. And I think even, some of the earlier arcade games had their CPU in discrete chips too. So like the Cinematronics games, they built that CPU from a bunch of chips, but it's a lot easier now. You have a language, and you can burn this to an FPGA if you want. There are instructions on how to do that.
Just absolutely incredible. Absolutely incredible.
You're going to learn how the oldest arcade games were made. This will help you understand that.
Awesome. Again, when I rediscovered this, right? So 8-bit workshop was something that you kind of go back to. I was like, I'm just going to continue to lose myself in this, right? Because it becomes this rabbit hole of, I forgot about this, and let me see how this works, and let me modify these things, and let me create my own, right? So just, absolutely amazing. Absolutely amazing. So I want to go ahead and take us out of the IDE for a minute and take a look at some other parts of the 8-bit workshop site here. So, of course, you mentioned your books that
Yep.
that you write and are selling, available at Amazon. So make sure you head on over there, check those out. Making games for the Atari 2600, 8-bit arcade games in C, designing video game hardware in Verilog. I'm definitely going to be checking that out. And making games for the NES. But you also have Dithertron.
Yep.
So maybe
So
explain this what we're looking at here.
This is a system that lets you generate graphics for a bunch of older systems, and these systems had a limited color palette. So you had to choose like 4 colors from 128 colors or 16 colors or whatever. But it helps you dither these into those 4, 8, 16, whatever colors, and lets you play around with different settings to make it look the way you want. And you can export when you're satisfied, you can export these into an 8-bit workshop project, and that'll show it on the emulated screen for you.
Amazing. So let's go ahead, and I'm going to go ahead and pull up the thumbnail from today's episode. Let's see if we can. Let's see if we can do that. There it is. So there you go. So then there's 8-bit workshop, and so this is what it would look like on a C64 in multicolor format. Let's go ahead and try it out in the Atari VCS. Oh my goodness gracious! There we go.
It's not meant for photorealism there, but at least you can see your face.
Yeah, there's your ZX Spectrum. That is not too bad. That is not too bad. I mean, it's getting most everything there. That is just crazy. Absolutely crazy.
Play one with the settings and it'll give you better results. But yeah, C64 had some good modes, as you can see. That's pretty good.
Yeah, that is. Oh, let's see what
NES has a different color palette.
Let's see, Master System. Oh yeah, look at that. Master System was legit. Master System was a whole lot more capable, I think, than people remember it being.
And a lot of colors.
Yeah. And really good audio too for the time, and sprite handling, right? Really pretty amazing. Okay, so we've got Dithertron here. Let's also go ahead and take a look at, you have a, let's see, a bitmap font generator. You also have this called the Player Pal 2600.
Yes, some Atari folks have, this is an external tool some Atari folks made that lets you make your own sprites and export them. So specifically for the Atari, so
yeah,
you can draw backgrounds and sprites and show the animation.
Right. So I'll zoom in a little bit here so you can see. So I could go ahead and create, something like this.
And then on the left side has a color definitions for each line. You have only one color per line.
Yep. And then I can go into this next frame, and I could go ahead and, I think I'm below that. I may be below it. I am. I'm terrible at drawing here with the mouse, right? So then I could go ahead and make it smaller, and then make it smaller yet again. And then let me see. How do I
do animation? I think.
Let's see. Scroll, flip, so I can. Oh, that's scroll and flip. Oh, view animation. There you go. So if I start the animation, there you go. You can see the sprite animating.
Looks like Robotron.
There you go. Exactly. Yeah, it's getting sucked down in there. So really, really cool that all of these tools are available, and for free for anybody to go in here and just start creating. Really just incredible. Really, really amazing. All right, with the amount of time we have left, what is the one thing that we haven't looked at yet that you really want people to go ahead and see?
Let's do basic.
Okay, perfect. Let's go ahead and do that. Let's go into basic. All right, so here we are. And we've got hello tutorial Steve benchmark, or Steve benchmark, not Steve or Steven benchmark. Interest calculator, craps, lander, hunt the wumpus, haunted house. What should we look at here? Lander?
Lander, yeah. Lander's a classic. So it's this is a basic, but it's a basic for mainframe. So if you ever want to program a mini computer, HP, or a DEC system using the basic of the time, this is your chance. Only text.
That is extremely cool.
Yeah.
Yeah, and so
And I
it's
have the
off.
original Dartmouth basic.
Let's see. Location is moon. I know it's cut up at the bottom of the screen. Standard conditions, and there we go. And it's going to start to go ahead and pull out all the information. Unfortunately, like I said, it's cropped off the screen a little bit because of the format. Somebody is asking in chat, what is this tool name? Sorry, I joined late. It is 8bitworkshop.com. 8bitworkshop.com. So make sure you head on over there, and all these tools are available through Steve's website, 8bitworkshop.com. Really, really cool. Do we have, let's see, Haunted House? Yeah, there you go. This is also a text-based one as well. And I used to love messing around with those and, change your own words. When you're a little kid, it's like, oh, I'm going to put ass in there and, stuff like that, right? And you're like, I hope, nobody sees this because I shouldn't be doing it. But yeah, you can go in.
I think it rather blue back then. Yeah.
Yes. All of the asses and, and butts, right? Which was the bane of the 3-letter high score in arcades, right?
Right. Yeah, I never did that.
Of course not. No, not at all. Not at all.
I think I was ace. I always put ace.
Very good. I like that too. So yeah, so you have a full basic editor here. Is this basic built? Which version of basic is this derived from?
It's a kind of a custom basic I made from. It's a JavaScript interpreter, but it kind of mimics all the different variants of basic you saw in mainframes, like the Dartmouth basic, HP basic, and so you can take a lot of these come from old tape archives. They're the original basic programs that just run on this interpreter. So
that is very cool. When you are loading a file from a PC, can you use an audio file? A tape file from PC to load in or not?
I mean, from a PC. I mean, yeah, if you have an audio cable and it supports, I don't think I understand the question though.
So my question is that if I had an old cassette tape from a version of BASIC and I wanted to go ahead and try to load it in here, can I do it using the audio file, or do I
not
need
for BASIC? No.
Okay.
No, but we don't have the basic interpreters because they're in the original ROM files. We don't have those on here. So
got it. Yeah, still absolutely amazing. Then you have your bitmap font generator as well, so you can go ahead and
easy way to make fonts and load them into your programs, or you can hand draw them. That's always fun.
I mean, but this is what we used to have to do on like the VIC-20 and those sorts of things, is use a character generator to go ahead and change the character sets to become the graphics that we were using on screen.
Cool little font. Yep.
That's right. Yeah, my first one, the first game I ever wrote that I did this with was called Space Debris, and it was great. I mean, it looked so, as a 12-year-old writing it, it looked fantastic to me, but just really incredible site, Steve. I mean, we could spend 3 hours here going through
we can make a game.
And yes, exactly. And maybe that's what we should do. Maybe at some point we do a rewind game jam. We do it through 8-Bit Workshop and see
what. Do it 3 hours. Yeah.
Yeah. Oh, okay. See. Yeah.
Export the cassette tape. Put on the cassette tape. You can find your VIC-20.
That is exactly right. Oh my gosh. All right, Steve, hang on just 1 second. Let me go ahead and move us over here. Thank you so much, Steve, for your time today. We really appreciate it. Everybody, please go ahead and check out 8bitworkshop.com to go ahead and get started on your game development journey. Somebody here in the chat said, how can someone start from scratch? What would be your advice to somebody starting this from scratch?
Well, I'm not just saying this because I wrote the books, but you should buy a book and read through it and look through all the other examples and just block some time off, several hours off to just get down and learn it.
Yep, and I would also recommend, and what I'd recommend is go to the website, pull up the system that you want to start learning about. I would start off with, an earlier system, take a look at the code examples and start reading through the comments, start executing those games and seeing what's being done, and then just start messing around with the code, start changing variables, start changing parameters, start changing the graphics, and you'll start to learn and understand how these games were created for those systems back then. Again, just an incredible teaching tool, incredible IDE, and yeah, I can't wait to dig into this some more. So, cool. Steve, thank you so much for your time today, buddy. We really appreciate it. All righty. And that brings us to the end of this episode of Rewind. I want to thank again my friend Steve for joining us today. Yeah, let's go ahead and give him another cheer there. Over there at 8bitworkshop.com. Make sure you go ahead and check out all the stuff. Make sure you check out Steve's books, also available on Amazon.com. So go ahead and check out his books over there. And I want to go ahead and just say, if you are a game developer of any size, from independent games to AAA developer, make sure you head on over to aws.amazon.com/GameTech. Check out all of the tools, technologies, solutions that we provide you to help you on your cloud game development journey. I also want to give this huge shout out to Waterflame. Yay, Waterflame, for allowing me to go ahead and use his music here on Rewind and all the other shows that I do on our AWS Game Tech channels. And if you care about video games and preserving its history as much as I do, make sure you head on over to gamehistory.org and check out the work that the Video Game History Foundation is doing to preserve video games and their history for future generations. I happen to be a founding board member of this 501c3, and they're doing some incredible work to once again preserve video game history for future generations. Head on over there and check them out. And with that, it brings us to the end of this episode of Rewind. Thank you so much. Have an incredible rest of your day and awesome weekend. And we will see you next Friday, 3 to 4 p.m. Eastern on Rewind.